It's the natural numbers less than 15. P are the prime numbers. M. Even numbers. Less. All right. Are we ready? We can do this. I believe in you all. Okay. I want P and E. Should stop saying what they are. P this E. Okay, and then cookie up. Okay. So natural numbers start at what number?
1.
1, 2, 3. Where am I going to stop at? 11, 12, 13, 14. Okay. I'm recording.
Settle down. Oh.
All right. Prime numbers.
2, 3, 5, 7.
Okay. Prime numbers, what's the first one?
2,
2,
3, 5, 7, 11, 13.
Done. Even numbers.
2, 4, 6, 8, 10, 12, 14.
Good units. I want not P as well. What's in not P?
Yeah.
1, 4, 6, 8, 9, 10, 12, 14.
You went too fast.
Okay. What's in P intersection E? This is the and symbol because it makes the word and. What's in P and E? 2. What's in P or E?
2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14.
12, 13, 14. Okay, what's in not P and E?
4, 6, 8, 10, 12, 14.
Now this one always seems confusing like this, so I tell you when they're both negated to rewrite it. Flip the symbol and the negation outside. So I want what's not in P and E. What's the only thing in P and E? 2. So we have 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Everything but 2. Okay. Yeah.
For like the even numbers, wow, even at 0. Oh,
Because the universal set is the natural numbers.
oh.
You need to tell me it was a burn. He was just asking a question. Ooh! Not looking at the ooh! It's like burning math people. It was a legitimate question. They were a little harsh on you. But, yeah. Rude. All right. No. Okay. What we do here is when we get a word, what's the first thing we always do?
Spell it out.
Rewrite it. Rewrite it. Pookie up. Pukia. Yep. It's from the Latin origins.
What's it mean?
It means green grass.
What?
Green grass.
Green grass?
Yeah. Yeah. It doesn't. I just made that up. Okay. Determine how many different words can be made. How many letters are in Pukia?
7.
So we get 7 factorial on the top, and what do we have to remember on the bottom? 2 factorial, 3 factorial, which is why we stack letters. We stack the letters to remind us that we have to divide by the factorials, right? What do you get for an answer?
420.
All right. So this page, we're still using the word answer, right? So we had A-N-S-W-E-R, and when I wrote it out, it's 6 letters, right? No doubling or tripling, so that just means I don't end up with a denominator. Okay? This one says that have the letters A-N-S adjacent. Adjacent just means side by side, and in the order A-N-S. So it has to be in that order. So let's look at it. We go 1, 2, 3, 4, 5, 6. A-N-S adjacent means A-N-S together in that order. So remember when I said that we have to put something together, we always hook it together, right? And we hook it together at the front. If it says A-N-S in that order, how many options do I have for blank 1? 1. It's just the A. How many for blank 2? 1. It's just the S, or N, sorry. And then blank 3? Uno. It's just the S. How many do I have left? Yeah. 3. So I'm going to have 3 for here, leave a letter behind, 2 for here, leave a letter behind 1, because we always box and hold when it's a word, because we don't have an unlimited amount of every single letter, right? Am I done now? What do I have to remember to do?
You gotta do that.
Oh, you have to times by 1 more than after step 4.
Yeah, so you've times by 1 more than this number, so 4. And the reason why is we have to count how many cases if I move them, right? So this would be 1 case if it was here, 2, 3, 4 if it was at the back, right? So you always times by 1 more than the number after the hooked together numbers. So this would be the same as 4 factorial, because 4, 3, 2, 1, and 1, 1, 1 does nothing, or 24. The next one says that have 3 letters A-N-S adjacent, so together, but not necessarily in that order. So now we still have to have the A-N-S adjacent or together. So we hook them together. But now the order doesn't have to be A-N-S. How does that change it? How many options do I have for the first blank? 3. It could be A, N, or S. And then I box and hold one. So say I hold the S. Then this would be A and N. So how many? 2. Say I box the N, then this would be A, which is 1. How many letters are left? 3, then 2, then. Am I done? I would be done if it said that A and S have to be adjacent at the front, right? If it said at the front, I'd be done because I wouldn't move it. But if it said together or adjacent, we have to times it by 4. It's 1 more than the number after the hook together. So it's 3 factorial, 4 factorial, which is what? 144?
Yep.
Example 4 now, I give you the different number of letter arrangements of the 6 letters in the word answer. What's the only difference to this one and answer?
2 A's.
There's 2 A's. You have to watch yourself. So we're going to have factorial, 2 factorial on the bottom. So you can get rid of half of the answers. So I rewrite my word always. A-N-S-W-E-A. So every single, someone's like, well, when do I not divide by 2 factorial? Never. So just get going. Like, I don't even need to, cool, this one's going to have it. Oh, so is this one. Like, I don't overthink it. That 2 factorial is going to go on the bottom of every single one the moment I have 2 A's. Okay? Now, the top you treat like you actually can't, that you can tell the difference between the A's. That those are all different letters. So if it says Determine the number of different arrangements of the 6 letters in the word and suite without restrictions. What am I going to have up here for the 6 blanks? 6, 5, 4, 3, 2, 1. I still go down by 1 number each time because I box and hold, which would get me 360. Now, if you see here, there's a B, there's a C, there's a D. I want you guys to try those out, please. Now it is. Let's pay attention. All right. Begins with an S. 1, 2, 3, 4, 5, 6. How many S's are there? 1. Then how many left? 5, 4, 3, 2, 1. 5 factorial over 2 factorial, which is 60. Thanks for the answer. All right. Begins with a vowel, ends with a consonant. 1, 2, 3, 4, 5, 6. How many vowels are in and suite? 3. So I begin with a vowel. How many options do I have?
3.
Wow. 3? How many vowels do we have? 3. Okay, so how many options do I have? 4. Okay, good, good. I feel very confident in this. I'm glad the test is not tomorrow. Consonants. How many consonants do we have? 3. And how many do we put here? Do not say 4. You're not funny. 3. Okay, how many letters have we used up?
2.
2. How many do we have left? 4. Yes. 4, 3, 2, 1. Shh. So, how they'll sometimes, guys, paying attention, please. How they'll sometimes write the answer here is they'll go 3 times 3, which is 9, times 4 factorial over 2 factorial, and they'll just leave it as a factorial answer. But I would like the actual answer. What did you get?
12.
That answer's equally as
I
good.
did it in my head.
Wait, this is
108.
108?
Yeah, 108.
This is
Better than
Wait,
12.
no, that was 12. I got one away.
Oh my gosh. You do know. It is 108. All right. Oh, that changed letters. Colors.
Oh, I think that's a different color.
Observant. Yes, you are. All right. That have 3 letters. Shh. A-N-S in the order A-N-S. That's where I'm going with this. 1, 2, 3, 4, 5, 6. 2 factorial on the bottom. These have to be together. Guys, if I was listening to this podcast, I'd be like, this teacher has no control. So don't make me look stupid. All right. A-N-S adjacent. So what do I have for the first blank? 1, second, third, then? Okay, am I done? No. Did it say together at the front? No, it said adjacent. So I have to multiply by 4, which gets me the answer of 12. Perfect. Okay, let's look here. So we have Frank, George, Hannah, Iris, Jacob, and Kim have playoff tickets for a hockey game in the adjacent seats A3 to A8. Now this, by the time you get to C, C is going to be more difficult, so I really need you guys to pay complete attention, okay? Or I will lose you on C. So A says, in how many different ways could they sit together in seats A3 to A8? So if you wanted to, you could visualize it by going like A3, this is seat A3, this is seat A4, this is seat A5, this is seat A6, seat A7, seat A8. All right. Now, are there any restrictions of who can sit where or do what? No. So how many options do I have for the first blank? 6. Then, is it 6, 6, 6, 6, 6 the whole way along? No, because someone needs to stay there and sit down and take that spot. So then what? 5,
4, 3,
2,
1.
1. What can we represent that as?
6 factorial.
Which is 720. Good answer. Okay. Now we get to the actual restricting part. So here it says, George and Hannah are dating, and how many arrangements in A would they be sitting together? So now we want to just make George and Hannah sit together. Does it say George is on the left and Hannah's on the right or anything like that? No, so we just need to make them sit together. So we still have our 6 seats. So we're sitting them together. right here. Am I dividing by any factorials? Are there any like people that look exactly the same in every single way and therefore you wouldn't no, they're people. So how many options do I have for this blank? 2, then 1, then 4, 3, 2, 1, times 5 because they're together, not just together at the front. So that's 240. Now this is where I'm going to lose you. It says just before the game, George and Hannah have a disagreement and decide not to sit together. In how many ways can this happen? Now, pencils down, paying attention. If I said to you, how can I figure out the people that are not in this class but are in this school? What would the fastest way be? To just like count all the people in the school? To be like, actually, could you step out of the bathroom, please? I need to count you. And then, oh, who's not here today? Who's outside? Who's that? Would that be the fastest way?
Go ask the principal.
Go ask the principal what?
How many people are in school?
No.
That's what
She wouldn't know.
Yeah, she would go in power school.
Nope.
Yeah, she
Not
knows.
allowed. Power
She
school's down.
knows.
How could we figure it out?
Subtract.
Subtract is a good start. Yes. Subtract what? I like that.
Subtract the amount of people that go to the school. Oh wait, no.
That we take people that go to school. Yeah, we can take that. We want the people who are not in this class. So we ask
Everybody
for.
but us.
Yeah. So you take the total number of. No. We're gonna get there.
You take the total number
Yeah.
of people in each class
In the school. Yeah.
and minus how many people are
Who are.
Are in this class.
Oh my gosh.
Okay. So.
Are in this class.
Are in this class. There we go. We got there. That took us a little bit, but that's okay.
Nobody.
All right. So what we are trying to do is we're trying to find the people not in this class. So the best way is to not just go count all the people not in this class. That would take way too long. You'd probably miss a couple. Or 10. That took you 5 minutes to decide to which to subtract. So we're going to miss a couple people. Like that's going to happen. Like it's going to happen. So instead of doing that way, instead of asking and finding all the people everywhere, what you guys said was right. You'd go to Mrs. Atkinson and you'd be like, Mrs. Atkinson, how many people are in this school? And she'd tell you, blah, blah, blah. I don't know how many.
Power school's down.
And then,
Can't do that.
power school's down, but she knows how many people are in this school. Yeah, she
all hard. Do you know how many?
900 and blah, blah, blah. And then if we subtract off how many people are in this class, what's left over are the people not in this class. We agree?
Yeah.
Okay, we're going to use that same reasoning to figure out how many people or how many ways these two don't sit together. So what I'll get on a test is I'll get people like drawing George and Hannah in first and third seat, then second and fourth seat, then first and fifth. Like that's cases, that's chaos, right? That's a lot of work and you're probably missing a couple. So the best way to do it would actually be to get the total number of ways all 5 kids can sit. All 6 people sit in the seats. So how many completely different ways can 6 people sit in 6 seats? 720, right? That's 6 factorial. So when you go somewhere with 6 seats and 6 of you are sitting down, you don't realize this, but there are 720 different ways you guys could sit in those seats. That would be looking different. Okay? That is actually true. And we showed it by doing this up here. 6 could go here, then 5, then 4, then 3, then 2, then 1. Okay? So that's the absolute maximum number of different seating arrangements I can have with 6 people. Right? Now, if I take off from the maximum number, 720, if I take off all the ways George and Hannah sit together, what's left over?
240.
No, what, like in words. What's left over?
500.
No, in words. If I take the total number of ways all 6 people sit in the seats, and then I subtract off George and Hannah sitting together, what's left over? All the ways that George and Hannah, someone just say don't read. Okay, that scared me for a second. Hannah, do not sit together. or don't sit together.
The answer is.
Because if I take off, out of all the 720 cases, if I take off all the ways they sit together, then what's left over are the ways they're not sitting together, right?
Yeah.
So this is where that 240 comes in, because up here it shows all the ways they sit together. So that's just 2 times 1 times 4 times 3 times 2 times 1 times 5. It showed up there. So that's 240. So there are 720 totally different cases I can make with 6 people, no restrictions. There are 240 of them where I can keep George and Hannah sitting together in different spots. There's 240 of them. When I subtract that off, I get 480 different ways where George and Hannah do not sit together. Okay? So whenever I ask you to not have something sit together or not have the vowels together, what you're going to do is total number of ways you can do the word, minus the ways the vowels together, and then what's left over will be the vowels not together. So let's try one out at the top of the next page. There's a blank spot at the very top. You're going to try this out. So I'm going to give you the word something short. I'm going to give you something short. I'm going to give you short. Okay. I'm giving you the word short. Are there any doubling or tripling letters? So there'll be no denominators, right? I want you to tell me all the ways that the R and T are not together. So you're going to do total minus the R and T together, and then you'll get the answer. So try this out. So we have to do short, the total number of ways I can rearrange the word short, which is 5 factorial, right? So that's total, no restrictions. We agree? Then I have to subtract off all the cases where R and T are together. So how do I do that? I go 1, 2, 3, 4, 5. I want to put R and T together. So I hook them together. And then I have how many options for here? 2, then 1. How many are left? 3, 2, 1. Shh. And then what do I have to remember to do? That's them together at the front. Times it by what? 4. You have to times it by 4 because there are 4 places that these could move, right? It's always one more than after the hook together number. So if it's a 3, you multiply by 4. Because there's 4 cases you could do. So it's going to be 120. There are 120 different words I can make out of short. And then this is 48. So I should be left with 72. So there'd be 72 cases. Example 6 has the word Canada. So the first thing I do when I get a word is I rewrite it. Correct? So why do I rewrite it? Yeah, so that you spot that you're repeating the A's. And that gives me a hint that every single question I'm going to do here is going to have a 3 factorial on the bottom because of those A's. Getting rid of all the cases where the A's actually are not different. Now here it says it must begin with a vowel and end in a consonant. There are 6 letters in Canada, so I go 1, 2, 3, 4, 5, 6. This 3 factorial just gets rid of all the cases where the A's actually look the same. The top, we treat it like the A's are different. So it must begin with a vowel. How many vowels are there in Canada? 3. So I put a 3 here. Yes, they have to all be A's. I don't care. That 3 factorial gets rid of the cases where it would look the same, right? Then it has to end in a consonant. How many consonants are there? 3. How many letters have I placed? 2. How many are left?
4.
So 4 then, 3, 2, 1. And what do I get for an answer?
36.
36. This one here says must begin with C and D in that order. So I still have the 3 factorial on the bottom because I still have 3 A's. I have my 6 letters. 1, 2, 3, 4, 5, 6. This one's different than the C and D must be together. It says that it must begin with C and D. So can I move them around after? No, they have to begin with C and D. And it has to be in that order. So how many options do I have for this? 1, 1, 1. How many letters are left? 3, 2, 1. Do I multiply by 4? Why don't I multiply by 4? Because it says the word begin. If it said together, then I would multiply by 4. right? But it doesn't say together, it says begin. So your actual answer is 1. Now here it says C and D must be together in that order. Does it say together at the front? No. So we still have the 3 factorial on the bottom. 1, 2, 3, 4, 5, 6. Must be together. So we're going to put them together in that order. So it's still 1, 1, 1. That didn't change, did it? The 1, 1, 1 stays the same. We agree? Then we get 3, 2, 1. But what's the difference between this one and the last one? Yeah. You multiply by 4 because it doesn't just say begin. So we multiply by 4, and so our answer is actually 4. Now this last one says C and D must be together, but doesn't say a specific order, right? It can be in any order, but they have to be together. Does it say together at the front? No, it just says together. So we're going to have 1, 2, 3, 4, 5, 6. C and D must be together. Doesn't say in that order. So how many options do I have here? 3, then 2, 1. Hold those. Then I've used up 3, so I have 3, 2, 1. If it said C and D must be together in any order at the front, I would be done. But does it say at the front? Just says together. This together means I have to find the cases. It's always one more than the number after the hook together. So it's going to be times 4. So I'm going to get 3 factorial, 4 factorial, over 3 factorial. The 3 factorials cancel, so it's just 24. Tomorrow we're going to finish this little example.